Welcome to Convert to Radians, a Pemberton Pre-Calculus podcast, Episode 3, using the Six Trigonometric Functions. For this first problem, we are given that the sine of 60 degrees is equal to square root of 3 over 2, and the cosine of 60 degrees is 1/2. We know these from our 30, 60, 90 triangle. They want us to calculate the tangent of 60, cotangent of 60, sine of 30 degrees, and cosine of 30 degrees. The tangent of 60 degrees is equal to the sine of 60 divided by the cosine of 60. The square root of 3 over 2 divided by 1/2, when we flip the second fraction and multiply, gives us square root of 3 over 2 times 2 over 1. When the 2's cancel and we reduce, we are left with square root of 3 for the tangent of 60 degrees. The cotangent of 60 degrees is the reciprocal of tangent 60 degrees. If we take 1 divided by tangent 60 degrees, the result from the previous problem, we have 1 divided by the square root of 3. Since we must rationalize the denominator, we multiply top and bottom by square root of 3, and we get the result square root of 3 divided by 3. The values for sine of 30 degrees and cosine of 30 degrees come from our 30, 60, 90 triangle. The sine of 30 degrees is the opposite side divided by the hypotenuse. Therefore, sine of 30 degrees is 1/2. The cosine of 30 degrees is the adjacent side divided by the hypotenuse. Therefore, the cosine of 30 degrees is square root of 3 over 2. Therefore, our final answers to our original problem are as listed here. Here is another problem where we are given the cosecant of an angle is square root of 13 divided by 2, and the secant of an angle is square root of 13 divided by 3. We are asked to find the sine, cosine, and tangent of that angle. Because we know that sine is the reciprocal of cosecant, we can take the reciprocal of cosecant, 2 over square root of 13, and then simplify it to get the sine. If you rationalize the denominator by multiplying top and bottom by square root of 13, we get that sine of our angle theta is equal to 2 square root of 13 divided by 13. The cosine of an angle is the reciprocal of secant. If we take the answer for secant and take the reciprocal of it, we get 3 over square root of 13. Multiplying top and bottom by square root of 13, by rationalizing the denominator, we get square root of 13 times 3 on top, divided by 13 on the bottom. The final one is tangent of our angle, which we know is sine divided by cosine. If we take the answer for sine, 2 square root of 13 divided by 13, and divide by cosine, 3 square root of 13 divided by 13, by taking the reciprocal of the second fraction and multiplying, the 13's will cancel, the square root of 13's will cancel, leaving a 2 on top and a 3 on bottom, resulting in the tangent of our angle equals 2/3. Therefore, the answers to the original problem: sine of our angle theta is 2 square root of 13 over 13. Cosine of our angle theta is 3 times square root of 13 over 13. And tangent of our angle theta is 2/3. In this problem, we are given that the sine of an angle is equal to 1/2, and that the angle is somewhere between 0 and 90 degrees. we are asked to find what is that angle in degrees and in radians. For this, we're going to refer to our 30, 60, 90 and 45, 45, 90 triangles. We know that the sine of an angle is equal to its opposite side divided by hypotenuse. So looking at our triangles, we have three different angles, 30, 45, and 60, as candidates to get an answer of 1/2. In order to check these, we check each one. The sine of 30 degrees would be opposite divided by hypotenuse. Notice that is 1/2, the correct answer for the problem. It would not be sine of 60 degrees because opposite side divided by hypotenuse would be square root of 3 over 2. And it would not be the sine of 45 degrees because opposite is square root of 2 divided by the hypotenuse 1 would give me square root of 2 over 2. So the correct answer is that the sine of 30 degrees is equal to 1/2. Therefore, my angle must be 30 degrees, or if I write it in radians, pi divided by 6. To convert from degrees to radians, you multiply by pi and divide by 180 degrees to convert to radians. This time we are given that the cosecant of an angle is equal to 2 and that the angle is between 0 and 90 degrees. Find the angle theta in degrees and radians. Again, we refer to our two triangles, the 30, 60, 90 and the 45, 45, 90 triangle. For this problem, because it's cosecant, we want to convert it into sines and cosines to work the problem out. We know that cosecant is the reciprocal of sine. So if we take the reciprocal of 2, we discover that the sine of the angle should be equal to 1/2, which, as we saw in the previous example, the sine of an angle being equal to 1/2 between 0 and 90 degrees is 30 degrees, or in radians, pi divided by 6. Given that the cotangent of an angle is equal to square root of 3 over 3, and the angle is between 0 and 90 degrees, find the angle theta in degrees and radians. Again, we need our two triangles, and from these two triangles we can derive the following. We know that cotangent is equal to cosine divided by sine. It's the reciprocal of tangent, which is sine over cosine. If the answer were cotangent of 30 degrees, then we would take the cosine of 30 degrees divided by the sine of 30 degrees. Using the triangles, the cosine of 30 degrees is square root of 3 over 2, divided by the sine of 30 degrees, which is 1 over 2, which will reduce to square root of 3. Cotangent of 45 degrees is the cosine of 45 degrees divided by the sine of 45 degrees. The square root of 2 over 2 divided by the square root of 2 over 2 is equal to 1. If the answer were 60 degrees, the cotangent of 60 degrees is cosine 60 divided by sine of 60. Cosine of 60 degrees is 1/2. The sine of 60 degrees is square root of 3 over 2. When I divide those, I get 1 over the square root of 3, which again, because we need to rationalize, the answer becomes square root of 3 over 3, which is the answer we are looking for. Therefore, the angle must be 60 degrees. And therefore, our answer will be 60 degrees, or pi over 3 radians. If we are given the secant of an angle is equal to square root of 2, and the angle is between 0 and 90 degrees, find the angle in degrees and radians. This time, again, keeping in mind our two special right triangles, we know that there is a relationship between secant and cosine. Cosine is the reciprocal of secant, and therefore we could look at the trig expression cosine is equal to 1 divided by secant theta, since they are reciprocals of each other. Since secant of theta in this problem is square root of 2, the cosine of the angle would have to be 1 divided by the square root of 2. Because we can rationalize the denominator, we get cosine of our angle should be equal to square root of 2 over 2. Referring to our two triangles, cosine of 45 degrees being square root of 2 over 2 from the 45, 45, 90 triangle gives us our answer. The cosine of my angle should be 45 degrees, or pi over 4 radians. For this problem, we now add some constraints to our trig functions. Let's say we are given that the sine of an angle is 3/5. The angle is in quadrant 2. Find the values of cosine, tangent, cosecant, secant, and cotangent, the remaining 5 trig functions. Because we're in quadrant 2, we must be aware of the positive or negative value of sine and cosine. In quadrant 2, cosine will have a negative value, and sine will have a positive value. From our given problem, we can construct a right triangle based on the sine of the angle equaling 3 over 5. Because we know that sine is opposite over hypotenuse, I can construct a right triangle such that the opposite side is 3 and the hypotenuse is 5 across from the right angle. Therefore, by the Pythagorean theorem, we can find the remaining side by using a squared plus b squared equals c squared, where c squared must be the hypotenuse. Since b is equal to 4 using the Pythagorean theorem, we are now ready to find the other trig functions. Based on this triangle, we already know that sine is 3/5 because sine is opposite over hypotenuse. That was given to us. We can now derive cosine and tangent by looking at the adjacent side over the hypotenuse, which will be 4 over 5, and tangent of the angle, which is opposite over adjacent, which is 3 over 4. Those values coming from the triangle we constructed. Cosine of an angle is the adjacent side over the hypotenuse, 4/5. The tangent of an angle is the opposite side divided by the adjacent side, 3/4. Because we are in the second quadrant, remember that cosine should be negative and sine should be positive. When we write in our answer for cosine, where we found that cosine was 4/5, it should be a negative 4/5 because we are in the second quadrant. Tangent, which is sine divided by cosine, should be a positive divided by a negative, giving a negative answer. And therefore, tangent should also be negative. The remaining 3 trig functions are the reciprocals of sine, cosine, and tangent. By taking the reciprocal of sine, we get cosecant, 5/3. The reciprocal of cosine is secant, negative 5/4. The reciprocal of tangent is cotangent, -4/3. For our final problem, let's say that we're given that the cosecant of an angle is equal to 4, and we are told that the cotangent of the angle is less than 0, meaning cotangent is going to be negative. With the knowledge that we were given, we know that since cotangent is negative, cotangent is cosine divided by sine. In quadrants 2 and 4, circled in blue, are where cotangent would be negative, because cotangent would be positive in the first and third quadrants. If you focus on quadrant 2 with the red circle, since cosecant is equal to 4, cosecant is positive, and cosecant is the reciprocal of cosecant is a reciprocal of sine, and since sine is positive only in the second quadrant out of the 2 circled in blue, we must be up here in quadrant number 2. So all of our answers must have a cosine value that's negative, a sine value that's positive, and all of the other combinations. So let's start with our knowledge that sine is the reciprocal of cosecant. Since we were given cosecant of an angle is 4, that must mean that the sine of the angle is 1 divided by 4, which we can now create a right triangle knowing that sine is opposite over hypotenuse. We can create a right triangle whose opposite side from the angle is 1 and whose hypotenuse is 4. You can do the Pythagorean theorem to find that the remaining side written in blue is square root of 15 on your own. To find cosine and tangent from the triangle, we can now calculate that cosine is the adjacent side over the hypotenuse. The adjacent side to my angle is square root of 15. The hypotenuse is 4. Therefore, cosine should be square root of 15 divided by 4. Tangent is opposite over adjacent. The opposite side from the angle is 1, and the adjacent side is square root of 15. However, since we need to rationalize the denominator, we will multiply top and bottom by square root of 15, giving us a tangent of our angle is equal to square root of 15 over 15. Remembering that cosine is negative and sine is positive in quadrant 2, we have the following answers so far. The sine is positive 1/4. Cosine being negative in the second quadrant would be negative square root of 15 over 4. And tangent, also being negative because it is sine divided by cosine, would be negative square root of 15 over 15. The remaining 2 trig functions, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Secant is the reciprocal of cosine, and so by taking the reciprocal of cosine, we get negative 4 over square root of 15. When you rationalize the denominator, you get negative 4 times square root of 15 over 15 for secant. Cotangent is the reciprocal of tangent. So when I took the reciprocal of tangent, I got negative 15 over square root of 15. Again, we should rationalize, and thus getting negative 15 square root of 15 on top divided by 15 on bottom. Notice that we can reduce the negative 15 and 15 here by canceling them out, leaving negative square root of 15. Therefore, our final answers for this problem are as follows. This has been a Convert to Radians podcast, episode number 3, using the 6 trigonometric functions. Thank you for watching.